This is Dr. N.R. Patil. Today we are going to see Kleins construction to find velocity and acceleration in a single slider crankchain. Let's start. So friends, let us draw a single slider crankchain. I hope everyone can draw this single slider crankchain like this. So this is a crank, this is connecting rod, then there is a slider, and you can have a fixed link number 1. So this is a single slider crankchain. If you see this single slider crankchain, OC is a crank where this point O, where it is pivoted, you know this is a pivot point. So this is a pivot. Then this is a connecting rod. Crank makes an angle of theta degree. So this is angle theta. So this is theta degree. And it rotates in a clockwise direction. So remember this. So this is direction of its rotation. And it rotates with uniform angular velocity of omega radians per second. So that's now how to draw a velocity diagram using Kleins construction. So this is very important. I have listed down here step number 1, step number 2, step number 3. Step number 1 is draw perpendicular through O to PO. So this is PO. You have to draw a vertical line here, perpendicular, isn't it? Then extend PC. This is PC, you have to extend it. The intersecting points will be somewhere here. So that is point P. So let's start how to draw. Extend the line, perpendicular, draw perpendicular to OP. Then extend the line PC. You will get the intersecting point somewhere here. Okay, this is point P. Now this triangle friends, OCP represents velocity diagram. How simple it is, isn't it? So simply you have to draw a single slider crankchain as per given dimensions with the scale. Then draw perpendicular vertical line through O. Then extend connecting rod here to get this intersecting point P. This triangle OCP is a velocity diagram. Now the same is drawn somewhere here. You can see. So this is OCP. Now what you have to remember is this CP. This is CP. This CP represents velocity of piston with respect to C. So this is very important. Now this vertical line OP, this OP represents velocity of P with respect to O, that is velocity of piston. And last vector OC represents velocity of C with respect to O. And when you rotate this triangle, you will get this triangle. So you may draw like this, or you may simply draw here only. And remember these three: velocity of piston with fixed point, velocity of piston with respect to point C, and velocity of C with respect to O. Okay, so that's very nice. You remember this, and if there is a problem in exam, you can easily draw it. Now friends, to find the velocities, this is the vectors, isn't it? Now these vectors you have to measure, and when you measure, you have to multiply it with angular velocity, omega into OC, omega into OP, and omega into CP. So this is very important, isn't it? So by simply drawing triangle, OCP will not give you magnitude of velocity, isn't it? You have to find it, and to find it you have to multiply the vector length into with angular velocity omega. Okay, so this is length, isn't it? So this length into omega will be VPC. So this way you can find. Now let's move further. Now acceleration diagram, friends, it's very easy. You have to remember this step number 1. Draw single sided crankchain as usual in the, how you have drawn in the previous case. Then locate M. Now you have located point C in the last figure, isn't it? Same is the case here. So this is point O, which is fixed pivoted. Draw perpendicular to OP and extend this PC to get this M point. Okay. So this is as usual what you how you are drawn velocity diagram, isn't it? Now the step number 3 is very important. Mark midpoint D. So you have to mark this midpoint of what? P and C. So this remember, PC is a connecting rod. You have to mark its midpoint. Then with center D and radius this much, draw a circle. Okay, you have to draw the circle with center D and radius equals to P or C. Okay, very good. Now step number 5. With center C and radius CM, you have drawn circle. Step number 6. Now there is one more. With center C and radius M. So this is the radius. Remember this. Okay. With this center C, radius M, draw one more circle. So this is the second circle, isn't it? So this second circle and this first circle will intersect at point K and at point L. So this is, they will intersect at point K and L. So if you read this, you can easily draw the acceleration diagram also. Now once you get this point L, extend this line KL, extend this line KL to get one more point on this OP line. You will get this point N. That's all, friends. So this quadrilateral QCO, QN and this NO, if I hatch this quadrilateral, so this quadrilateral, friends, represents acceleration diagram. So I have written here OCQN, OCQN, OCQN represents acceleration diagram. Okay. Now, so this is OCQN. You can see this is Q, C, ON. And when you join this NC, you will get acceleration of slider P with respect to C. So remember, friends, QC represents centripetal component of acceleration of P with respect to C. CO or OC represents acceleration of centripetal acceleration of C with respect to O. This NO represents acceleration of piston with respect to O. And this QN represents tangential component of acceleration of P with respect to C. So you have to remember all this. You have to measure the length and multiply it with omega square to get acceleration. I hope you understood this. So thank you very much. You practice few examples from book and you will get it. So thank you very much.